Hello. So today we're going to talk about how to write the equations of a quadratic, and the focus is going to be on vertex form. Excuse me. So let's highlight this here. So we are going to focus all day today on vertex form and how to write a quadratic in that form. But before I do that, let's kind of review vertex form. Let's make sure we can find a vertex. Because we're going to ultimately use that to write the equation. So I have a few slides to review vertex form. All right, so to familiarize yourself with what it looks like. With vertex form here at the top, we have these H and the K. Those values tell me my vertex or the location of the vertex. We do need to make sure, because it's a minus H, we're always going to use the opposite of what we see there. So for example, for in this problem, because it says -5, my vertex is going to be at a +5, 1. Okay. So again, opposite of what's inside the parentheses, and then we keep what's on the outside of those parentheses the same. Okay. I have a second one, just so you can see another one. All right. So I have a new quadratic in vertex form. Feel free to pause. You can try to figure out the vertex yourself. All right. But my vertex here is going to be a -6, -8. Again, opposite what's in parentheses, same as what's on the outside of parentheses. Okay? All right, what if I were to give you a graph? Can you find the vertex for a graph? Now, the vertex, when given a graph, is where it bends. Okay? It's that minimum in this case. It's the absolute minimum. All right? So that vertex is at a -2, -3. All right. So if I give you a graph, you can also identify the location of the vertex. All right. Here's another one. In this case, it's my maximum. It's the highest point on my graph. And if I draw a little dot here, you can see that the coordinates for this point are going to be at 1, 7. All right. So again, just familiarizing yourself with vertex form and vertex, just reviewing a little bit of some stuff that we've discussed previously. But the goal of today's lesson, or the goal of this video, is to be able to write the equation of a quadratic. So I give you a graph of a quadratic, and we want to be able to write the equation, right? We want to be able to write the function that represents this graph. Okay. So when I do that, I am going to start with my formula for vertex form. And this is something I want you to commit to memory. I want you to know vertex form by heart. Okay. Now, when I do that, I also want to know where the vertex is. And this vertex is at the point 3, 1. Now, when I write the equation, I also need a second point. Now, that second point is anywhere where your curve hits the grid at a nice value. So if you follow this curve, right, I want to know where this curve hits my grid marks, where I'm not approximating. I know exactly where it's going to hit. So I have one. The y-intercept for this problem is actually very nice, 0, 7. Now another, hold on, I'll get my pen to write here. Another value that you could use if you wanted to is over here. This hits the grid mark really nice as well. This is at 5, 7. You could use either one of those points. Okay, it doesn't matter which one you pick. I'm going to pick the y-intercept here, 0, 7, just because it's easier to plug in zeros than anything else. So I need a vertex and a point to write this equation. All right, and I'm going to do this step by step. So I'm going to start, I'm going to write y equals, and I'm going to plug in the vertex. So x minus the h. Now, minus the h means I'm going to take the opposite of my vertex value, which was 3. So I'm going to say -3 squared plus 1. So if you notice, I substituted the x and the y of the vertex into the location of h and k for my formula. Okay? And then second, I am going to take my point, which is an x and a y value, and I'm going to substitute that in for my x and y. Now, be very careful. Make sure you put the right numbers in the right place. The y value is 7, and the x value is 0. Okay? Once I have all those values in there, I'm going to simplify and solve. So I get a equals 0 minus 3 is a negative 3 squared plus 1. Negative 3 squared is 9. Now, I write this as 9a plus 1. And I'm going to solve for a minus 1. So I get 7 minus 1 is 6 equals 9a. And if you divide by 9, now I have my calculator here. If you do 6 divided by 9, you get 0.6 repeating, which I'm just going to write as a 0.67. So the equation for my vertex is a y equals a. Oh, I don't want to write a, right? What is our a value that we just found? So y equals, the a value is 0.67. X minus my vertex, which was 3 squared plus 1. And that is the equation for my quadratic. So here's the steps that we need to do. 1, make sure you know vertex form. 2, make sure you know where the vertex is and a point. 3, I'm going to plug in the vertex. I'm going to plug in the point. And then solve for A and get your answer. Okay? I got a lot of examples for these. We're going to go through them one by one. All right? Feel free to pause it. Do them on your own. Check your work. All right? Here is my next graph. So again, I'm going to go through the same steps. Vertex form. I'm going to write my formula. You're going to write it so many times you're going to know it by heart. Then I'm going to find my vertex. So I'm on my graph. This vertex is at, let's say, 1, 2, 3, 2, 3, 4. So it's at the coordinates 3, 4. Now I need another point. Okay, so I need to know where this curve hits very nicely. So anywhere where the curve hits the grid marks, really nice. So I'm going to use this point, which is at 2, 3. So if I write the equation for this quadratic, I can say y equals a x minus, now I'm going to plug in my vertex, 3 squared plus 4. Then I'm going to plug in my point. So the y value of the point was 3. The x value of the point was 2 plus 4 at the end. So now I want to simplify and I want to solve. So 2 minus 3 is a negative 1 squared plus 4. I'm going to square my negative 1. A negative 1 squared is a positive 1a plus 4. Excuse me. Excuse me. All right. So now I want to subtract 4 from both sides. I get a negative 1 equals 1a. Divide the 1, and I get a to be a negative 1. So my equation for this quadratic is going to be a negative 1 x minus the vertex, which is 3. Don't forget your squared, plus 4. Again, my vertex was at 3, 4, and my a value was a negative 1. Okay? And I got about 100 more of these, so we'll do one at a time. Watch as many as you need. Okay, we'll finish up with some word problems. All right, so I'm going to start with my formula, just like before. I'm going to find the coordinates for this vertex. So my vertex is at 1, 2. I need to pick one of those other points. It doesn't matter which one you pick. I'm going to use the one on the right here, 3, 3. And I'm going to substitute in the vertex. So x minus my h value, which was 1, squared, plus 2. Don't forget your squared. Now I'm going to plug in my point. The y value was 3. The x value was 3. So I have 3 minus 1 is 2 squared plus 2. 2 squared is 4, so now I have a 4a plus 2. Subtract the 2. So 3 minus 2 is 1 equals 4a. Divide the 4, and I get a to be 0.25. So my equation is going to be y equals 0.25 x minus my vertex, which was 1 squared plus 2. And that is the equation for my vertex, or for my quadratic and vertex form. Okay. I have another one. Again, I have a bunch of these. Eventually, they'll start to change a little bit, but I'm going to start, practice makes perfect, a x minus h squared plus k. I want to identify the vertex. So again, if you look at the graph, negative 1, comma 3. Is my vertex. I also need one of these points, so I'm going to use the point over here, 0, 5. So if I write my equation with my vertex, x plus 1, because remember you have to do the opposite, plus 3, because the vertex was a negative 1, so that means I have to use a plus 1 inside. Then I'm going to put the point in there, so my y value is 5, the x value is 0. So now I have 5 equals, I'm going to simplify. So 0 plus 1 is 1 squared plus 3. 1 squared is still 1, a plus 3. So I'm going to subtract the 3. 5 minus 3 is 2. So I know 1a equals 2. Divide by the 1, and I get a to be 2. So my equation for this quadratic is my a value, which is 2, times x minus my value. So if you subtract a negative 1, that's really just plus 1 squared plus 3. And that is the equation of my quadratic in vertex form. Okay? So this one I did in words instead of pictures, right? I actually mistyped here. So that should be the word the. So write the equation of the quadratic function given the vertex of the graph is 514 and the point is 7.2 is located on the curve. Okay, so again, I'm going to start with my vertex form. And I'm going to put my vertex. Now I know where my vertex is at 514. So I'm going to say x minus 5 squared plus 14. I know my extra point is at 7.2. So the y value is 2. The x value is 7. I'm going to simplify. So a 7 minus 5 is 2 squared plus 14. 2 squared is 4a plus 14. If I subtract the 14 over to the other side, I get a negative 12 equals 4a. And if you divide the 4 over, you get a negative 3 to be your a value. So my equation is a negative 3 x minus my vertex plus 14. And this is the equation of my quadratic in vertex form. So write your formula, plug in your vertex, plug in your second point, simplify it, solve it, and write your equation. Okay? All right. Another one, just like it. So we're going to do those same steps. Write our equation, So our formula, x minus h squared plus k. I'm going to plug in the vertex. So the vertex is the minimum. The minimum would be the vertex. So a x, now instead of a -5, I need to use the opposite, plus 5 squared, plus my k value is 8. So I put in the vertex. Now I'm going to put in the other point. So the y value is 26. The x value is a -2. I'm going to simplify. So -2 plus 5 is 3 squared plus 8. I'm going to square that 3, which gives me a 9a plus 8. Subtract the 8. I get 18 equals 9a. And if you divide the 9, you get a to be 2. So my equation in vertex form of this quadratic is 2x minus my vertex, which would end up being a plus 5 squared plus 8. And this is my answer. Okay? Again, feel free to pause. I know I'm going a little fast. Slow down, pause it. You could try to do it on your own. Okay, rewind if you need to. Now, my last two problems are the same idea. They're just in kind of an application form. They're no different, though. Don't get freaked out. Don't feel like they're more challenging. We just need to, I always like to draw a picture, okay? It says a member of the golf team tracks the trajectory of a golf ball, okay? So I'm going to draw my little guy down here. He's going to hit a golf ball, okay? And it says the golf ball reaches a maximum height of 12 feet after it's traveled a horizontal distance of 8 feet. So it reaches a height of 12 after it traveled 8. So that means that the coordinates of this vertex are my x comma y, 8 comma 12. Remember, always your x value first. Your x is your horizontal. Your y is your vertical. So that's why I wrote the 8 first and the 12 second, x comma y. Okay. Now it says the ball lands on the ground. So that's at the end here. Lands on the ground 16 feet away. So it traveled 16 feet. Okay. So this point is going to be at 16 comma 0. It's on the ground, so the height would be 0. Okay. But if you look at my picture, I have a vertex and a point. So to write this equation, we're going to start with our formula, x minus h squared plus k. So y equals a. I'm going to put in my vertex, x minus 8 squared plus 12. I'm going to put in my point next. So the y value was 0. The x value was 16. And I'm going to simplify. 16 minus 8 is 8. 8 squared is a 64a plus 12. I'm going to subtract the 12. I get a -12 equals 64a. Let me fix my pen here. There we go. And I need to divide by 64. We will get a decimal. Okay. So if I do a -12 divided by 64, I get my a value to be a -0.1. I'm going to round it off to 9. So my equation is y equals a -0.19 x minus the vertex, which was 8 squared plus 12. This is the equation for the quadratic of that golf ball. All right. I have another one of these. So again, pause, look through, okay, make sure you understand. I just want to make sure I have all these written down for you with a little explanation. So this one, Tommy gets frustrated with his Chromebook. He throws it into the air. All right, so let's draw a picture real quick. Here's Tommy. He's got his Chromebook. Okay, he gets frustrated. He throws it into the air. The computer reaches a maximum height of 20 feet after it travels a horizontal distance of 10 feet. So this point, this maximum, is my vertex. It traveled 10 feet, and when a height of 20 feet, my vertex is at 10, 20. The computer then lands on the branch of a tree 8 feet up and 14 feet away. So if I go 14 feet away, there's a tree here, okay? And it lands in this tree 8 feet up. So it's going to be 14, 8. Again, all of these values, you have to make sense of the numbers. You have to read it, make sure you understand the scenario here. But the picture helps a lot. So the tree was 14 feet away. The computer landed in the tree 8 feet up. So the 14 is your x, the 8 is your y. So now I want to write the equation. Y equals a, x minus h squared plus k. So y equals, I'm going to put my vertex in there, x minus 10 squared plus 20. I'm going to put my point in there, so I have 8 equals a 14 minus 10 squared plus 20. I'm going to simplify. So I get 14 minus 10 is 4 squared plus 20. 4 squared is a 16a. Subtract the 20. So I get a negative 12 equals 16a. And if you divide the 16, again, dividing the 16, negative 12 divided by 16 is a negative 0.75. So the equation for my quadratic is a negative 0.75 x minus my vertex minus 10 squared plus 20. And this is the equation for my parabola. Okay, that's the last question that I have. Feel free to email me or let me know if you have questions, and I'll be happy to help.